We are with module 1, and in the last session we discussed about the derivation of the Nash equation and few thermodynamic factors, basic thermodynamic factors we discussed about, and the continuation of the chapter is next is reference electrodes. Okay, so in this session we will be discussing about the reference electrodes. In that we study about the construction and working of a calomel electrode. What are reference electrodes? Reference electrodes are the electrodes with reference to which the electrode potential of other electrodes can be calculated. There are two types of reference electrodes. They are primary reference electrodes. Example is standard hydrogen electrode. This you should have studied in your previous classes. And secondary reference electrodes are under secondary reference electrodes. Okay, why the secondary reference electrodes came into existence? And why are we using only the secondary reference electrodes? Why are we not using the primary reference electrode? That is because before we should use only the primary reference electrodes, that is standard hydrogen electrode. The difficulty there was, it will be getting poisoned. Okay, the platinum metal present inside will be usually getting poisoned easily due to the impurities present in the hydrogen gas. And one more difficulty was, it is difficult to maintain the 1 atmospheric pressure of the hydrogen gas. Okay, that was one more problem. And the next problem was, the potential was varied with the variation of a temperature. Okay, due to these difficulties, hydrogen electrode is no more used nowadays. Secondary electrodes came into existence. Okay, and due to the difficulties caused by she, that is, the potential will be varying with the variation of the temperature, and the electrodes gets easily poisoned due to the impurities present in the hydrogen gas. Fine. And it is difficult to maintain the 1 atmospheric pressure of the hydrogen gas. Secondary reference electrodes came into the existence. So what are the secondary reference electrodes? These are the electrodes having constant and reproducible potential. Very important. You have to write this key point, then only you will be getting the marks here. You have to write they have constant and reproducible potential and are used to determine the electrode potential of any unknown electrodes. Okay, these are the electrodes which are used to determine the electrode potential of any unknown electrodes, and they are having a constant and reproducible potential. Okay. Next, construction and working of the calomel electrode. Okay, the electrode consists of mercury at the bottom of the tube. Mercury is covered with a paste of mercury and mercurous chloride. The commercial name of the mercurous chloride is a calomel, and the KCl solution is introduced into the tube through the side tube. A platinum wire will be inserted up to the bottom of the electrode, serves for external electrical connections, and the electrode is coupled with any other electrode through the salt bridge, and the calomel electrode will be acting as both as cathode as well as anode, depending on the nature of the other electrodes. Okay, see the diagram of the calomel electrode. This is the diagram. At the bottom of the electrode, mercury will be placed, and on that mercury and mercurous chloride mixture will be there, and on that either the three types of KCl is used here, either saturated solution of KCl, standard KCl, or decimal solution of the KCl will be used here, and there will be a side tube. Okay, that is called as a filling hole. Okay, what happens for after long time usage, the electrode will be, sometimes it will get dried, or the solution which is present inside the electrode, that may got leaked, or some problems will be happening. So the electrode will not work. In such situations, we have to make new solutions of the KCl, and we can fill through the side tube. And important, you have to write the salt bridge here. Salt bridge helps in a movement of ions, both positive and negative ions, in a equal velocity, to avoid the liquid junction potentials. Okay, in these electrodes, in calomel and in AgCl electrode, it is must to write, either you have to write a salt bridge, or you must show the presence of a porous membrane. Okay, that indicates it allows the movement of the positive and negative ions in a same velocity. Fine, so that we can avoid the junction potential. Clear, no? So about the diagram, what and all you have to write here. At the bottom of the electrode, it consists of a mercury, and on mercury there will be a presence of a mercury and mercurous chloride. The commercial name of the mercurous chloride is calomel. That's why the electrode is referred to as a calomel electrode. And there will be a presence of a platinum wire which is dipped until the bottom of the electrode, that serves for external electrical contacts, and a KCl solution will be present at the top. What type of KCl solution? Either saturated solution of KCl or standard solution or decimal solution of the KCl will be present. Okay, the type of the whatever the type of the KCl solution used, the electrode will be named like that. If we use saturated solution of KCl, the electrode will be called as a saturated calomel electrode. If we use a deci-normal KCl solution, that is called as deci-normal calomel electrode. Okay, if we use normal KCl solution, it will be called as a just calomel electrode. Fine. And the electrode will be acting as a anode as well as cathode, depending on the nature of the other electrodes. Okay, depending on the nature of the other electrodes, the calomel electrode will be acting as anode as well as a cathode. And the potential of the electrode potential of the calomel electrode is given by Nernst equation. E is equal to E naught plus 0.0591 by N into log of chloride ion concentrations. Okay, so it is clear from the above equation that the potential of the calomel electrode will be depending on the concentration of the chloride ions. E is equal to E naught plus 0.0591 by N into log of chloride ions. Okay, so it is clear that from the above equation that the potential of the calomel electrode depends on the concentration of the chloride ions. Okay, when we use for example, for 0.1 N KCl used, the potential will be showing 0.33 volts. For 1 normal KCl, the potential is found to be 0.28 volts, and for saturated KCl, the potential is found to be 0.24 double volts. Okay, so depending on the concentration of the KCl solution used, okay, the potential of the calomel electrode will be varied. Okay, please to remember this. You have to write this in your exam. Okay, it's very important to write. For 0.1 N KCl, potential is found to be 0.33 volts, and for 1 normal KCl, the potential is around 0.28 volts, and for saturated KCl, the potential is found to be 0.2422 volts. Advantages are coming to the advantages. It's easy to construct. Okay, in the case of the standard hydrogen electrode, it is difficult to construct. As I said, it is difficult to maintain the concentration of the hydrogen gas at 1 atmosphere pressure, right? Here this electrode will be very easy to construct, and the potential does not vary with the variation of temperature. Okay, here in the case of the secondary reference electrodes, the potential does not vary with the variation of temperature. They have constant and reproducible potentials. And coming to the applications of these electrodes, these electrodes we are already using in lab, I think. Okay, when this electrode is combined with the platinum electrode, it is used in the determination of potential. Okay, potential of the redox titrations. Okay, when this electrode is combined with the glass electrode, it is used in the determination of pH. Okay, the application of this electrodes are when it is combined with the glass electrode, that comes under ion selective electrodes, it is used in the determination of pH. And when this electrode is combined with the platinum electrode, it is used in the determination of potential of the given solution of redox titrations. Okay, this is about the platinum. This is about the construction and working of the calomel electrodes. The important points to remember here are, what are secondary electrodes means? Secondary reference electrodes means these are the electrodes having constant and reproducible potential. You have to write a neat label diagram. It consists of mercury at the bottom, mercury and mercurous chloride on that, and on that either 0.1 N, 1 N or saturated KCl will be present. A platinum wire will be inserted until the bottom of the electrode serves for external electrical contacts. There will be a presence of a side tube to fill the solution, and there will be a presence of a salt bridge or porous membrane to avoid the liquid junction potential. The electrode will be acting as both anode as well as cathode, depending on the nature of the other electrodes. Okay, and the potential is given by the Nernst equation. E is equal to E naught minus 0.0591 by n into log of chloride ion concentrations. Okay, so that when we use a 0.1 n KCl, the potential is going to be 0.33 volts. Okay, for 1 n it is 0.28 volts, and for saturated solution of the KCl it is a 0.2422 volts. Okay, and applications are, it is used in the determination of potential and in a pH when they are combined with the platinum and ion selective electrodes respectively. Thank you.